Now in this video, I'm going to show you how to create a statement-based dichotomous key using the tree, which was step 1 that we have already created. Now this tree can be found, or the creation of this tree can be found in the first part of our little video series. Now, I want you to remember that this is going to be very easy to do, mainly because we created a very simple tree. Now, if I refresh your memory, A was this bottle of water, B was the rock, which is here, C was the pencil, D was the plastic box, and E was the notebook. So we have the water, the rock, pencil, box, and notebook. Now these are all very, very different things, which means that we didn't have to really work hard at all to find differences and to create the statements to use in our key. Now that may not be the same. Sometimes you will have to pair statements in order to separate things. For example, instead of just saying, is it made of plastic, you might have to say, is it made of plastic and has a snap top? Or if I use an example from our lab on the heliconia, does it have a leaf width that falls between 50 and 75 centimeters and red bracts with red cheeks? So if they don't have leaves that fall within that range, and because you must satisfy both statements, if they don't have red bracts, then that would be one thing. And if they do have leaves that fall within that range, they also have to have red bracts, and that would be another option. Which is why it's always good to record as many characteristics as you possibly can, so that if you need to pair some of them together, that is not a problem when you're going to create your key. Now, I also wanted to mention that it is possible to use some statements twice, but it has to be on opposite sides of the tree. Now remember, we used is it cuboid over here. Now this statement only refers to A and D. It does not refer to B and C. So the rock is technically kind of square shaped, kind of cuboid. So if we had to, we could have used is it cuboid here to separate B and C as well. So you can use the same statement, but they must be on different branches of the tree, because you cannot use a statement that has basically been used to separate items already. Okay? Now, the other thing that you need to remember is that you should choose statements that are not ambiguous. Something like, is the rock cuboid, would be very ambiguous. And you also have to be careful that the statements you're using are true not just for the individual specimen you're looking at, but true for the entire group. So all of these shale-like rocks are not going to be cuboid. So if I brought a rock and it happened to be a slightly weirder shape, then I would have a problem. I will acknowledge that my statement about the length is kind of wonky as well, because some rocks may be a little bit bigger than this one. But again, this is just a simple exercise that we're doing so you can understand the basics. Alright? So let's get on with it, creating our statement-based key. Now, first thing we have to remember with our key is that we're using paired statements. Remember, dichotomous really means, or dichotomy means to cut in two. So we're asking questions that gives us two possibilities, which is generally going to be it is or it is not, which is the same as yes or no, etc. So our first statement, number 1, the first thing we chose is it plastic? Now 1A was a positive response, so yes, it is plastic. 1B was negative, no, it's not plastic. So we're going to say it is plastic, which is more of a phrase for using English here. you should really expand this and say the object is plastic, or the object is not plastic. I'm just really shortening it because my paper is kind of short. So we have our two statements. Where do we go from here? Now, this statement, base key, is very similar to a scavenger hunt. And you know, with a scavenger hunt, every time you find a clue, that clue directs you to another clue. So every time you answer the question correctly and you follow the answer, it leads you to another question until you eventually find your prize, which is the same thing that we're doing. So is it plastic? That has to lead you somewhere. So let's have a look back at our tree. Yes. And that leads us to statement number 2. So we're going to put some dots here and number 2, which will guide our user to go to statement number 2. The second part, it's not plastic, takes us to statement number 3. So we will send our user to statement number 3. Now, it's very important that your key be chronological. So we're doing all of our statements in order. So the next statement we're going to write is statement number 2. So you come to statement number 2. What we use was, the question we use for number 2 is it black? So we'll write down that statement. The object is black. Option B being that the object is not black. Now the question is, where would these take us? We have a look at this. There's only one object that is black and made of plastic, and that is the notebook. So that takes us straight to the notebook. So we've separated our first object. And when it's negative, that takes us to number 4. Now again, remember, we're not going directly to number 4 because we're going in chronological order. And what would also help you is if at the beginning you simply just wrote all of the statement numbers down the side, so you don't get mixed up about the order. What you'll also realize is that your number of paired statements is going to be n minus 1. N being the number of objects you're using to create your key. So because we started with 5 objects, A to E, we know that n minus 1 would be 5 minus 1, which is 4. So we know that we're going to have 4 pairs of statements, or 4 steps in our key. So you can just write them straight down the side, and that avoids any confusion when you're actually writing out your statements. Now, number 3, we go to our key. And you see how easy this is because we put the numbers in. So when you create your key, you have to remember to number them. And we also put the letters in, showing us exactly which type of statement was A and which was B. So that makes it very, very simple when you come to convert your tree into your statement key. Okay, so number 3. Statement is it greater than 3 inches in length? That's fine. So we have again a yes or no. However, for this one I put A as no, and the B made the same mistake I told you not to make. Didn't label this, but we know that that's B, and B is yes. So A would be the object is not greater than 3 inches in length. Whereas B is positive, the object is greater than 3 inches in length. Where did these statements take us? Well, we only had 2 items to divide, so they took us to the 2 items. So the rock is the only thing that is less than 3 inches and not plastic, whereas the pencil is the only thing that's greater than 3 inches and plastic. So if it is not greater, it's the rock, and if it is greater, it's the pencil. And our final statement pair, number 4, question we use is it cuboid, positive or negative again? A being positive, B being negative. So the object is cuboid. The object is not cuboid. And again, we had two things to divide, so we're down to, if it's cuboid, it's the box. Put that in here, and if it is not, it's the bottle. Now, you notice that I kind of mixed these up a little bit, which, now that I think about it, was very wrong. So what we're really doing is determining the letters, because technically you don't know what these items are. So this really should have been B and not the rock, and this should have been C, not the pencil, because you're not sure what the items are. Over here, the box is D,